Hello everyone. Today we are going to solve our next question on LeetCode, that is jump game second. So yesterday we have solved one problem that was jump game first. So this problem is the extension of the previous problem. So in the previous problem, what we have done, basically we had given an array in that problem and we have to return true or false on the basis of number of jumps described in that array. We have to tell whether from 0th index could we reach till the last index by using these jumps. But this question is a little bit different. It is saying that we have given this array, nums array, and in this array, each element is representing that how many jumps you can take, means how many steps you can take from every element. And it is saying that you have to return the minimum number of jumps you can take to reach to the last. So this is how this question is different. And it is saying that test cases are arranged in a way that you can always reach to the last index. But you have to tell that what would be the minimum number of jumps you will take to reach to the last. For example, if you will take this example, 2, 3, 1, 1, and 4. Now from here, if you will try to go till the last, then one possible way is take one step, and from here you can take three steps. So here the number of jumps is equal to 1 plus 1, that is equal to 2. Another step that we can perform is take one step, take one step, take one step, and from here take one step. So this is another way. Here the number of steps is equal to 4. The number of jumps is equal to 4. Another thing we can done is take one step from here, take two steps from here, and take one step from here. So this is another scenario. Now in this, if we will see, then the minimum number of jumps we can take to reach from this 0 index to the last index is equal to 2. So this is our final answer. So now let's try to solve this. So this is the array we have taken to solve this. Now if we will see that what we have to do, from a source we have to reach till the destination, where our source is this 0th index. From here we have to reach till this destination. So this is the source and this is the destination from where we have to reach. Now if we will see that, let's say we have three different ways to move forward. So this is one way, this is second way, and this is third way. From here you can take one jump, and this jump include only one step. From here you can take two jumps. From here you can also take one jump, and this jump include two steps. And from here you can take one jump which includes three steps. And from this is, let's say this is the intermediate position, IP1, IP2, and IP3. So this is the intermediate position. Now from this intermediate position, there are multiple ways to reach to the destination. There are multiple ways to reach to the destination. Now let's say from this intermediate position 1, you will take two steps to reach to the destination. From this intermediate 2, you will take three steps to reach to the destination. And from this intermediate 3, you will take four steps to reach to that destination. So what will be our final answer? So the final answer will be like the minimum number of jumps in all of these jumps will be our final answer. So the minimum number of jumps we are taking is equal to 2. So our final answer will be these jumps from intermediate to destination plus this jump from source to uh, intermediate. So which is equal to 2 plus 1 equal to 3. So minimum number of jumps here we can take is 3 to reach from source to destination. Now this problem is a DP problem. So we will try to solve this using DP. So if we can see that the larger problem is on left side and the smaller problem is on right side. Why I'm saying this? See, from this position, from this destination, there is no need to go somewhere because you are already at the last index. But from this source, you have to take multiple steps to reach till the destination. So the larger problem is on left side and the smaller problem is on right side. So we will start solving from it from right side. So what we will do, we will simply use memoization technique. We are going to use memoization technique of DP to solve this. So what we will do here, so here we will take an array which is equal to the size of this array. So we will take an array So this is our original array, that is nums, and this is our DP array. So what we will store in this DP? So what we will store? Let's say if we have to store some value here, then here we will store that from this position, how many minimum number of jumps we can take to reach till the last. Similarly, if we have to store here, then here we will store that from this index, how many minimum jumps we can take to reach till the last. So this is what we have to store in this DP array. So let's start. Now, if we will see that here, let me write index first, 0, 1, 2, 3, 5, 6, 7, 8, and 9. Now, if we will see that, if we will talk about this ninth index, then this is the final destination where we have to reach. So here there is no need to take any step further. So here the number of step will be equal to 0. Now we come here at this place. At this place, how many number of steps we can take to reach till the destination? So basically it is equal to 0. So we cannot take any step to go further. So here it is equal to null. Now again, we will come here at this position. From there, it is saying that you can take 2 steps. From index 7, you can take 2 steps. Either by taking 1 step, you can come here at this place on index 8, or by taking 2 steps, you can reach here. Now, here we are taking 2 steps, but this is a single jumps. 2 step doesn't mean that we are taking 2 jumps. No, we are not taking 2 jumps. Here we are taking here we are taking a single jump, but that jump includes 2 steps, 1 step and 2 step. So this is what the difference between the step and jumps. So here either we can take 1 step or we can take 2 step. So if we will take 1 step, then here as there is null, so we cannot move further from here at this place. If we will take 2 steps, then by taking 2 steps, we will reach till the destination. So what minimum number of steps we have to take, minimum number of jumps we can take from this place. So the minimum number of jump is equal to 1 from this place. Now let's move further. From this place, we can see that either we can take 1 step, or we can take 2 steps, or we can take 3 steps. We cannot take 4 steps from here. Why? Because if we will take 4 steps, we will go out of the loop. So that we do not have to turn. So we can take either 1 step, 2 step, or 3 steps from here. Now, if we will take 1 step from here, then from this place, we have to take 1 step to move further till the destination. Now, if we will take 2 steps, we will reach here, and from here we cannot move further. And if we will take 3 steps from here, then we will reach till the destination. So the minimum number of steps, minimum number of jumps we can take from this place to reach till the destination is equal to 1. We will take 3 steps and go till the destination. Now let's move further. We will come here at this place. Now from this 2, either we can take 1 step or we can take 2 steps. If we will take 1 step, then we will reach here at 6th index, and from this 6th index we have to take 1 jump to reach till the destination. And if we will take 2 steps, then we will reach on index 7, where we have to take 1 jump to reach till the destination. So either we will take 1 step or we will take 2 steps. We have to take 2 jumps to reach till the destination from this 2, which 1 jump is this and 1 jump from here to these intermediate positions. So here the total number of jumps will be equal to 2. Now let's move further. Now from this one, from 4th index, there is only one option. We can take only 1 step. That is 1 jump. So if we will take 1 step from here, by taking this 1 step, we will reach on index 5. And from index 5, we have to take 2 steps to reach till the destination. This DB is storing that from a particular position, how many steps you can take or how many jumps you can take to reach till the destination. So this is what this DB is storing. So as this is 1, here we can take only 1 step. So by taking 1 step, we will go at 5th index, and from this 5th index, as it is representing that we have to take 2 jumps to reach till the destination. So the total number of jumps that we can take from this 4th index is equal to 1 plus 2, that is 3. So from here we can take 3 jumps to reach till the destination. Now let's move further. Now, from this 2, we have two options. Either we can take one jump or we can take two jump. Now, if we will take one jump, then by taking this one jump, we will come here at fourth index. And from this fourth index, we have to take three jumps to reach further till destination. And if we will take two steps from here, then by taking these two steps, we will come to index 5. And from index 5, we have to take two jumps to reach till the destination. So minimum number between 3 and 2 is 2. So what we will do, we will simply take two jumps, and after taking, we will simply take two steps, and after taking these two steps, we will reach on index 5, and on from index 5, we will take two jumps to reach further till the destination. So here we will take 2 plus 1, that is equal to 3 jumps. Now let's move further. From this 0, as this 0 is representing that we cannot take any jump, so here it will be equal to null. From now, from this 3, either we can take one jump, one step, or we can take two step, or we can take three steps. Now, if we will take one step, then by taking one step, we will reach to index second, where it is the value is equal to null. So we cannot move further from here, from this position. If we will take two step, we will reach at this position, third index, where from where we have to take three jumps to reach till the destination. And if we will take three steps, then by taking these three steps, we will reach till on index 4. And from this index 4, we will take three jumps to reach till the destination. So between these both, 3 and 3, as both are equal, so the minimum number of jumps will be equal to this 3 plus 1. One jump from here to any of these two intermediates. So basically it is equal to 3 plus 1, that is 4. So from this first index, we have to take 4 jumps to reach to that destination. Now again we will see from this 0th index, either we can, as it is saying that you can take 3 steps. So either we can take one step from here, either we can take 2 steps or 3 steps. Now, if you will take one step, you will reach at index 1, from where you have to take 4 jumps to reach at the destination. If you will take 2 jumps, you will reach at second index, from where you cannot move further. And if you will take 3 steps, then you will reach at third index, from where you can take 3 jumps to reach till the destination. Now the minimum number of jumps between this 4 and 3, as we would not consider this null case, as from here we cannot move further. So between these 4 and 3, the 4 is greater and 3 is smaller. So what we will do from here, we will take 3 jump, we will take 3 steps, and by taking these 3 steps, we will reach at index 3. And from here, by taking these 3 jumps, we can reach till the destination. So minimum total number of jumps from here will be equal to 3 plus 1, that is equal to 4. So from here, we can take 4 jump to reach till the destination. So now we are at 0th index. So this is our final result. So from our source to destination, we have to take 4 jumps to reach till the destination. So this is how we are going to solve this. Now let's try to write the pseudocode for this. For that, here we have to implement this function jump. So let's implement this. So basically we have this jump function. We have to implement this, and nums array is given here. So what we will do, we will simply take a DP array, and we will take this DP array of integer. Instead of int, we will take integer here, because if we cannot take any jump, in that case, here we are storing null. So to store null, we are taking integer here. So we'll take DP of integer, new integer, and it is equal to the length of this array. So nums of length. Now what we will do, as we know that if we will start from this last index, then there is no need to take any step, because we are already at the last index. So here we have to take 0 jumps to move further. So we will store 0 at the last index. So what we will do, dp of n minus 1. Let's say n is equal to the length of this array. So dp of n minus 1, that is representing the last index, which is equal to 0. So here we will store 0. After that, we will start traversing from this last second index. So for int I equal to n minus 2, I greater than equal to 0, and I minus minus. Now we will start from this n minus 2 position and we will go till this 0th index. Now what we have to do? So basically this element of our array is representing that how much steps we can take. So here we will take n steps, and these steps is equal to this nums of I. Now what we will do? We have to loop till these steps, that how many steps we can take from here. And before that, we will take one minimum variable, which will be equal to the maximum value of integer initially. So it is equal to the maximum value of the integer initially. Now let's start looping from here. Now for int j equal to 1, because the minimum number of jump that we can take is equal to 1. So we'll start from this one. The minimum number of steps we can take is equal to 1. So j equal to 1, j lesser than equal to steps. And here we have to check one more condition, that this I plus j should be smaller than the length of this array. Now, if you see in this case, then from here, either we can take one step, or we can take 2 step, or we can take 3 step, or we can take 4 step. But if we will take 4 steps from here, then it is sending us in the last of the loop, after the loop. So basically, from if we will take 4 steps from here, we will go out of this array, in this nums array. So we will simply cross the limit of this array. So here we have to check one more condition, that I plus j should be smaller than n, where n is equal to this length. So here from this 4, either we can take 1 step, 2 step, or 3 steps. We cannot take 4 steps, because if we will take 4 steps, we will go out of this array. So that's why we have to check this also. After that, we will do j plus plus. Now, what we have to check? Now, if we will check that if dp of I plus j is not equal to null. So we have to check for null. In case it is null, we will not consider this. And dp of I plus j is lesser than minimum. Now, if this dp of I plus j is lesser than minimum, in that case, what we will do? We will simply replace this min by this dp of I plus j. So in that case, what we will do? This min is equal to dp of I plus j. So this is what it is. Uh, so we have replaced this min here from dp plus I, dp of I plus j. And at the last, we have to check one more condition, that if this minimum is not equal to integer dot max value, when it will be equal to integer dot max value? Let's say there is a case where this 4, instead of this 4, there is 1, and instead of this 2, there is 1. So now from here, we can take only one jump. So if we will take one jump, we will reach here where there is null. So this element will also be null in that case. And from here, if we will check, then from here, we can take only one jump. So by taking this one jump, we will reach here, and here there is already null. So this element will also be null. So basically, if there are all values that we are checking and all of these are null, then in that case, we have to check this condition, whether if this minimum variable is not tampering, is not changing from this integer dot max value. That means we have found each and every value is null. So if this is not equal to integer dot max value, that means there is a change in minimum value. So in that case, what we will do? In that case, we will do dp of I equal to minimum plus 1. So we have found this value. After that, finally from this, we have to return dp of 0, which is the final result of ours. So this is what the pseudocode for our problem. Now, if we will analyze time complexity and space complexity for this, then the time complexity in worst case is equal to of n into n. This n for the outer loop that we are taking here, and this n is for inner loop that we are taking for the number of steps. So basically, if these number of steps, let's say equal to m, so basically it is equal to O of n into m. And if we will see it, then approximately it is equal to O of n squared, that is quadratic time complexity. And if we will talk about space complexity, then as we are taking this dp array to solve this question, then and this dp array is equal to the length, the size of this dp array is equal to the length of this nums array. So basically it is the space complexity is equal to O of n, which is linear space complexity. So now let's try to solve this. So initially here we will take one dp array, and this dp array we will take as integer because we have to store null in this, equal to new integer, and the length of this dp array is equal to the size of this nums array. After that, what we will do, uh, initially we are starting from last index. So at the last index, we will store for this. Let's extract the length of this array into a variable, and we will store the last element as 0, as there is no need to take further steps when we are at last index, because this is the final destination of ours. After that, what we will do, we will start traversing from last second index, I equal to n minus 2, I greater than equal to 0, and I minus minus. After that, here we will take steps, that how many steps are there, and these steps is equal to nums of I, and we will take minimum value, and its value is integer dot max value initially. After that, let's loop through these steps, that it is saying that how many steps we can take. So for int j equal to 1, because we will take minimum one step, j lesser than is equal to steps, and we also have to check this condition whether at any point of time this I plus j should not be equal to should not be smaller, should not be equal to or greater than n. So if it is lesser than n, then it is okay, and j plus plus. After that, what we will do, if dp of I plus j is not equal to null, and dp of I plus j is lesser than minimum, then here we will update the value of this minimum as dp of I plus j. And after this, finally, when we will come out of this loop, uh, we will check that whether the value of minimum is tempered or not. If the value of minimum is tempered, and now if it is not equal to integer dot max value, that simply means there is a change in the value of minimum. In that case, we will store this dp of I equal to minimum plus 1. One step to go from the particular index to the intermediate, and then the further steps that are equal to minimum. So that's why it is equal to minimum plus 1. After that, we will come here, and from here we will return dp of 0, which will store our final result. Now let's try to run this, and all test cases are accepted here. Let's try to submit this, and it is accepted. So that's all for today. Thank you.